All right, so we mentioned integers last class period. Does anybody remember, I don't know, how we described them, I guess. What did we do to describe integers? What are they?
They're basically like whole numbers, just with negative numbers.
Right. They're like whole numbers, like 1, 2, 3. Do they include 0? Yep, they include 0. And then they also include, like Preston just said, the negatives of those values. Those are integers. So these are whole numbers, just like you said, very nicely done, with assigned value, positive or negative. And I don't mean to say that excludes 0. It certainly doesn't. 0 is included in there as well, because 0 is a whole number as well. Now, sometimes people get frustrated because they're like, negatives don't exist in real life, but let me assure you that they do. And so I'd like to give you a couple of real-world examples where you see negatives really used. So one of them where you see them used is in temperatures. Shake your head if you know what I'm talking about. Is anybody here from a cold state? I mean, like something north of Oklahoma. You all from Oklahoma and Texas? Everyone in this room is? Wow, okay. Well, it really does get colder than Oklahoma and Texas, believe it or not. So if one example is that it could be 50 degrees Fahrenheit, and you all would be wearing pants and jackets and telling me how cold you are. That's what my teenagers would really be doing. They really don't like the cold 50-degree temperature. Or it actually could really actually be negative 50 degrees Fahrenheit, like my friends in Minnesota have from time to time. What? I know, it's crazy. My husband used to do this ministry where we did food delivery, and they would go and they would unload the truck in Ohio. So when we lived in Ohio, and they would unload the truck at like the wee hours in the morning, like 4 a.m. in the morning in the middle of the winter, and it literally was in the negative 30s to negative 40 degrees. They had on gloves and really heavy clothing and things, but it really got that cold, okay? So this is really possible, negative temperatures, all right? Another possibility is that we could talk about feet above sea level. You can be 1,000, for example, feet above sea level. I didn't go and look up what Oklahoma is, but I think we're probably more than 1,000 feet above sea level. We're certainly above sea level. All right? But you could also be negative. So negative 1,000 feet above sea level. Now, we don't often say it that way if we were saying it. How would you feel would be more natural to say that you're negative 1,000 feet above sea level? We would usually say 1,000 feet below. That's kind of how we would talk. You might even say 50 below in terms of a temperature instead of saying negative 50. You might, right? So a lot of the times, it's not that we don't have signed values. We just use different language to express them than saying positive or negative. So I'm not going to ask for a show of hands, but I want you to think. Have any of you gone negative in your bank account? Do any of you have a car loan? Are you taking out student loans? Those are all negatives. That's what they really are, okay? Those are negative values in a financial world. So we have lots of things that are positive and negative values. Now, we started talking about last time number lines, and we really only looked at the positive side. We were talking mostly about decimal ordering last time with number lines. But I did mention that on a number line, we have negative values to the left, positive values to the right, and this is the same description I had written down last time too. Smaller numbers to the left, larger values to the right. Didn't change that. But what we're going to look at now is we're going to look at how we would plot a positive number versus a negative number. So I want to have us plot 10 and negative 7. For the most part, it helps us to have that reference point of 0. So I'm going to put a 0 somewhere in there. I don't even care if it's halfway between. It doesn't really matter. If we're looking at the number 10, we need to be above 0. And on a number line, that means to the right of. So I'm going to make 1, 2, 3, 4, 5, 6, 7, 8, 9, and here is my 10. So where am I going to be if I put down -7? To the left, and I'm going to count out 7. And I'm going to label that that's -7. Now, in terms of the number line itself, what do? Well, I just put a dot on the number line. If you like colors and you want to use a color, go for it. But at the very least, it needs to be distinguishable enough from the line that I can see the dot. Okay, so if you're doing something on like a worksheet or something, sometimes that means you need to make it more like a big old polka dot, just because that's the way it is, okay? Make it distinguishable. So some other sort of weird looking things are stuff like this. We're really comfortable, because we work with positive numbers more, at writing 9 less than 10, right? But somehow it feels very uncomfortable to write -9 is greater than -10. It's correct. There's nothing wrong with what I wrote. It just feels a little weird because we focus in on the 9 and the 10 part, and we don't think about the fact that the negatives are backwards. But if you think about it from a number line perspective, and I'll just do the number line perspective for the negatives because I don't think the positives are a concern for us mostly. So here's 0, oops, let me put there, here's 0. And if I were to plot -9, I'd go 1, 2, 3, 4, 5, 6, 7, 8, and there's -9. And the next one would be -10. So from a number line perspective, these are my points, right? Which one's smaller, the -10 or the -9? -10. If you want to think about it in terms of value, which one's further below sea level, -9 or -10? -10. If you borrow $9 or you borrow $10, who are you more indebted to? Person you borrowed $9 or $10 from, right? -10 is smaller than -9, okay? So it's -10 is actually, so one of the ways you could write that, differently than I've already written it, is that -10 is less than -9. But if I switch the order around, I can also say then that -9 is greater than -10. Those are equivalent statements. So take a look at the two examples below. You can use any of those 4 symbols that you would like, which means everything has 2 possible answers. But use an appropriate symbol to fill in the blank on each of those options. -3, -10, 2, -5. What symbol could work between them? Okay, on the first one, -3, -10. Which one's smaller? The -10. Everybody good so far? The -10 is smaller. So we talked about last time that we want then our direction of our inequality to open toward the larger value. In this case, that would be the -3. So this symbol would work, or the one that has the equal sign underneath. Either of those are appropriate in that blank spot because the -3 is bigger. It would come further to the right on the number line. How about 2 and 5? Which one's, I'm going to circle it again as smaller because I already did it that way before. Which one's smaller? The -5. The easiest way to think about that one is what? It's negative, right? The other one's actually a positive number. So I don't want to focus on 2 and 5 here. I do need to focus on the fact that the values actually, one's positive, one's negative. So again, what symbol should go in that blank then? The greater than or the greater than or equal to symbol. So either of those options in that blank would be just fine. It was a number of years ago now, but I have a brother-in-law who is now, I think he's 41. He's about to be 41. And he went back to school as an adult. and he was taking a class much like this one. Actually, it started at a little bit lower level, and he really, really struggled with the idea of integers and whether or not when you add them, subtract them, multiply, and divide them. And he was like 30 at the time, okay? So I have some very distinct memories of him asking me questions about integers, and so I'm going to try to answer you in a way that helps you to understand if you were struggling with some of those same concepts. We're going to look at addition and subtraction first. So with addition and subtraction, there's really three things that we need to talk about. One is what to do when the numbers have the same sign. They're both positive or they're both negative. One is what to do when one of them is positive and one of them is negative. And the other is what to do if you see a negative, like a subtraction of a negative. You know, like minus a negative is how we usually think about it. What do I do with minus a negative? So the first one, the same signs. When we have the same signs, both positives or both negatives, we're going to add the values and keep the sign. So if the sign was already positive, you're adding two positive numbers, the answer will be positive. If you're adding two negative numbers, the answer will be negative. What happens if they're different signs? Well, if it's different signs, we will subtract, and this is going to sound funny, but we're going to subtract the larger number, ignoring the signs. We're ignoring the signs. We're going to subtract the larger number minus the smaller number. And use the sign of the larger. So for example, if I had negative 7 plus 5, they're different signs. 7's negative, 5's positive, correct? So ignore the signs. If I just think about the 7 and the 5 and I subtract them, what do I get? I get 2, and then I use the sign for the larger value. The sign of the larger value is a negative. It's 7. So this gives me negative 2. If I were to go back up, I should have done an example up here when I said this. If up here I had, I'll use a similar one, negative 7 minus 5. They're the same signs. So I'm going to add them. What is 7 plus 5? Ignore the signs. Just what's 7 plus 5? It's 12. And the sign on both of these numbers is negative, so the 12 is also negative. This is the one that tripped my brother-in-law up, the subtracting a negative and understanding, well, but why? I mean, like, I can tell you what to do, but why? Why does that work? Well, let me give you an example. So to subtract a negative, what we do is it becomes a positive. You probably know that, but you may not know why. So let me give you an example, and I'll show you on a number line why it makes sense, okay? So here's a 7 minus a negative 5. If what I'm telling you is correct, this should be 7 plus 5, which is the number 12, right? That's what it really should be. So let's look at a number line and find out why does that make sense. And there's more than, this isn't the only way to explain this. This is just a nice one considering we've talked about number lines already. So here's 0, here's 7, and here's negative 5. What subtraction is it's finding the distance between two values. So, whoa, I didn't mean to do that. Hang on. What is the distance between negative 5 and 7? It's 12. And we'll talk more about distance. I think it's at the end of this lesson as well. But it's 12. There are 12 spaces, not hash marks, but spaces between negative 5 and 7. And that's why this works. It's because we're really counting distances when we're doing this. All right? Okay, so I have 4 examples for you to do. We're not going to spend too much time doing them because I really think you guys know how to do this. I just wanted to give you some grounding, some reminder if you haven't done math in a while, whatever. I would like for you to work through these 4 problems. Once you've worked through these 4 problems, turn to that neighbor. If you're not sitting next to a neighbor, get close enough that you can have a neighbor. And just make sure you have the same answers that they do. And if you differ, figure out why. You're done with the 4 problems. Share with a neighbor, compare your answers. Okay. You guys good? Go. Has everyone checked in? If not, check in with somebody nearby you. We'll run through them real quick, make sure that throughout the class we have the same answers. Good? Okay. It's okay if you mess up. Now you have a chance to correct it, right? On the first one, are they the same signs or different signs? It's the same signs. So when it's the same signs, what do? We add the value. So what's 6 plus 7? 13. And what sign is on both of them? A negative. So this is negative 13. 2. Are they the same signs or different signs? They're different signs. So what do? We subtract them. So the bigger values is 7. Smaller values is 6. 7 minus 6 would be 1. Is it positive or negative?
Positive.
How come?
Because the larger one.
The larger one, 7's positive. Good. How about the next one, number 3? Same signs or different signs? Different signs, so we subtract. Ignoring the signs, 15's bigger than 13, so it's 15 minus 13? 2. What's the sign on this one? Negative, because the 15's negative. Number 4, what do you see happen on that one? I have a minus a negative, right? Or minus a negative, I said it right. So I have 6 plus 2 if I adjust that. And then, of course, 6 plus 2 would be 8. Excellent. Any questions on those? Okay, well done. Multiplication and division. So let's take a look at this one. No surprise. Positive times positive is a positive. Second graders know that because they don't even know what negatives are, right? We're all good. A positive times a negative is a, somebody know? A negative. And then a negative times a negative is a positive. Not only that, but honestly, no matter how many positives and negatives there are, if there are an odd number of them, you're going to get a negative. I'll show you why with an example here in a second. And if there's an even number of negatives, you end up getting a positive. So we're going to do a couple together. And it works for multiplication and division. There's nothing different. You multiply and divide whatever you would have done when you learned multiplication and division in 3rd, 4th grade-ish, 5th grade maybe, depending, okay? And then the signs are the only thing that are different because we're working with negatives now as well. All right, so here's a few examples. Don't write them all down, just work with me as we go, okay? On the first one, you notice that there is a positive 6 and a negative 3, correct? So I have a positive and I have a negative. So what will my sign be? It'll be negative. And then 6 times 3 is 18. Okay, the multiplication and division shouldn't be a sticking point. I'm not going to go throwing big O numbers at you that you're going to be like, where's my calculator? These are single digit kinds of things, okay, or simple double digit things here in just a second. 8 and 4. These are actually both negatives. There's 2 negatives here, yeah? So what happens when I have 2 negatives? I get a positive. You can write plus if you want, just as a reference point. If you leave it off, I'm going to assume you meant that it was a plus, so it doesn't matter to me either way. What is 8 times 4? 32. Some of you are like, wait a minute, maybe those flashcards were, something that was important. We're working on flashcards with my 4th grader right now. It's important. All right, so let's shift gears just a moment to division. The division's no different. I have a negative and I have a positive. So what will my answer be? It will be negative. And then what's 16 divided by 2? It's 8. Number 4, there's a negative and a negative. So what's my answer going to be? Positive. Again, if it helps you to remember you checked, write it down. If it doesn't matter to you, don't. What's 12 divided by 3? It's 4. All right, so 5 and 6 are examples of what I was kind of getting at when I talked to you about evens and odds just a moment. Notice here on number 5, I have a positive, and I have a negative, and I have a positive. Now, let's be honest. The positives really don't change things, right? It doesn't matter. I've got 1 negative. So this answer is going to be negative. I'll come back to the number here in a second, but let's just jump down to the next one. This one is a negative, and a negative, and a negative, and it's really negative. Should really, smile some more or something. There's a lot of negativity there. There's 4 of them, right? But you can put them in pairs. So what happens when I take 2 negatives? What do they become? Positive. They become positive. And if I take 2 more negatives, they become a positive. So the reality is, if I have an even number of negatives, I can always pair them up, and then they don't have as much negativeness, right? Y'all are grinning at me, but you're going to remember it, right? You are. Like, that's the deal. Okay, so this answer will end up being positive. Thank you. Y'all are fun. Okay. It does not matter when you're working with all the same operation which ones you do first. So if you want to multiply 6 times 2 and then multiply that times 3, fantastic. But my personal preference is to multiply the 3 and the 2 first because it keeps the number smaller. What's 3 times 2? 6. And then if I take that 6 times the first 6, I end up with 36. No matter what order you do it in, you're going to end up with 36. Kind of the same thing on the next one. Personal preference, would like to kind of pair them up. What's 2 times 3? It's 6. And then what's 4 times 5? 20. So what's 6 times 20? 120. And sometimes there's natural and nice ways to pair things up, and you just go with it. Okay, I mentioned before, and this is the point where I was remembering from my notes, is that we are going to talk just a touch about distance. We've already broached the subject a little bit. The distance between 2 values is really the larger value minus the smaller value. So if we want the distance between 2 and 6, it's really just 6 minus 2. 6 minus 2 is 4. And from a number line perspective, kind of like I drew earlier, these happen to both be positive. I'll put my 0 on here just for fun. Here's 2. Here's 6. And the distance here, again, counting spaces, not hash marks, but spaces, is 4. There are 4 spaces between. Oh, I guess I had a number line already drawn on my book, on my page, and I didn't use it. Look at that. Now it's there. Okay, so thinking about it in that way, they don't have to both be positive, right? I used 2 and 6 as example, and they were both positive. But what happens if you did -6 and 2? So what I said was that it should be larger value minus smaller value. And I really mean like the value including the sign. Which of those two numbers, -6 or 2, is the larger value? The 2. And the smaller value is the -6. So I ended up with a minus a negative, didn't I? Did. But what did we say that minus a negative meant? It's equivalent to being a positive. What is 2 plus 6? 8. So there's 2 ways to do this problem. One, I just wrote out numerically. Some of us think like this. Maybe it's you. Some of you are like, that whole minus a negative thing is tripping me up, and you're a visual person. I actually am a visual person. I mean, I can memorize rules, but I like visuals a lot. And it helps me to see them. So I've got the number -6. I've got the number 2. And I can see from this picture why it should be 8. So if you're dealing with something and the numbers are small enough, I don't care which of these 2 work pieces you show, but you should show something. All right? Pick your favorite. Draw the number line or write it out as a subtraction statement and then simplify and give your solution. Any questions on that? All right.